stuff for all of chapter 12. I just wanted to print out one thing instead of blue and one over there. So this chapter we're going to start talking about naming. So today we'll go over some of the naming, and then next time we'll talk more about naming. So this naming alkanes is, we're going to talk about that next time, but that's on there if you want to work on some Alex. So we're going to talk about naming normal alkanes, so just a normal carbon chain. We're going to talk about how to number a carbon chain, and then some common side chains. So we use this term, we call this an alkane. So anything that's just a boring carbon molecule, it's just got carbon single bonds and hydrogen single bonds in the chain, that's called an alkane. All right? I don't know why. And then we have these different titles for different lengths of carbons. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's undecane. So the prefix for 11 is und, I guess. What is 12? Dodecane. So if I tell you that I'm working with octane, you should know that has 8 carbons. It's an 8 carbon chain. If I tell you undecane, this is the weirdest one, but I have seen it coming up in Alex. If I say undecane, you know that I'm working with a carbon chain that has 11 carbons. Okay? All right, so then on your chart, I gave you this. In one column, it has the number of carbons in the chain, and then this is what we call that type of carbon chain. So if I have 1 carbon, that's called methane. If I have 2 carbons, that's ethane. If I have 3 carbons, that's propane. 4 is butane. 5 is pentane. 6 is hexane. 7 is heptane. 8 is octane. 9 is nonane. 10 is decane, and 11 is undecane, and 12 is dodecane. Okay. So those are the ones that I have. I think that those ones are the ones that we're going to have to know. So some of these are familiar, or like hexane, that makes sense, it has 6. Hept is 7, oct is 8, that makes sense. The ones that sometimes trick me are these first 4. So someone, when I was learning this, they said monkeys eat peeled bananas, and that has stuck with me, and that is how I remember methane, ethane, propane, butane. 1, 2, 3, 4. So that's something that helps me. If I can come up with, I don't know if it's a mnemonic device, but some way to remember the order, that's helpful for me. So if you wanted to go through and figure out a way to remember the whole list, that might be a good idea. Or again, for this, you get 1 note card. On the final, you'll get the front and back. Huh?
It's just the first 4 that are difficult.
Right, yeah, so that helps me. The monkeys eat peeled bananas. Or you could come up with another one. Okay, and you have this chart on your paper as you're learning those. So then, when we are naming, we need to find the longest carbon chain. This is going to be really important for the next day when we talk about naming. So we need to figure out, it doesn't matter if it's a side chain, it doesn't matter, we need to find the longest carbon chain. Okay, so we have some examples over here. So we just look 1, 2, 3, 4, 5, 6, that looks like the longest carbon chain. We could also count from this 1, 2, 3, 4, 5, 6, and that is equivalent to counting from this because both of these methyl groups are on the end. It doesn't really matter if we start on one or the other. Okay, but it does matter the order. So if I start at this end, 1, 2, 3, 4, 5, 6 carbons, then this methyl group is at position 5. What we want to try to do is number so that we have the side chain, the substituent, we want that to be at the lowest number. So if we start here, 1, 2, then that methyl group is at group 2 instead of group 5. So this is really kind of a weird thing. I think it gets a lot easier if you practice. So this is something I would do as many examples as you can. Because this is pretty straightforward, but some of them get really weird. And then there's all sorts of, well, what if they're both the same? Then we'll talk about a few exceptions. Okay, questions so far? Okay, here we go. So let's look at this example. So this is kind of hard because it's just kind of confusing. So we just kind of look through and say, oh, what if I start over here? 1, 2, 3, 4, 5, 6, 7. That gets me 7. But then my first group is at 3. And my next group at, oh, that's an equivalent actually. 1, 2, 3. Oh, but then I'm missing this methyl group. Okay, so we've got 1, 2, 3, 4, 5, 6, 7. So I could either number this way, 1, 2, or 1, 2. They both have a methyl group. That's equal. But if I go this way, I have 1, 2. There's a methyl group at 2. And then 3, this is an ethyl group at 3. So if I go this way, the methyl group is at 2, the ethyl group is at 3, and then I have another methyl group at 6. If I go the other way, 1, 2, the methyl group is at 2. But then, so 1, 2, 3, 4, 5, my ethyl group is at 5, and my other methyl group is at 6. So if I number this way, then that reduces the number of the ethyl group. So I just want to try, if it's equivalent, so either methyl group at 2 or 6, it doesn't matter which direction. If I number from the group that reduces the number of the constituents, then that's the way I want to do that. Okay, questions on that?
So it doesn't matter which direction you go, as long as the side chains, the majority of them are smaller.
Yep, as long as the side chains are at smaller numbers. And you want to reduce the number, the first one, the smallest, and then the other ones you can just look at it. I think this is most easily learned by practicing it. So this is something that I would practice. Okay, let's look at. Okay. So let's look at these examples. So I have a carbon here, or this is a methyl group over here. I need to know what spot it's at. So I could go, let's turn on my pen tool. Come on, pen. That's been working so good. Oh, that didn't work. Why is the pen not working today? Oh, it appeared at the bottom. I don't know what's going on. I might have to turn the other pen on. Okay, we're just using the other pen. If you're okay. Oh, dang it. Why is that? Oh, it's this one. Okay. All right, so I can number from this carbon 1. Why is this How do I, there we go. 1, 2, 3, 4, 5, 6. Then I have 4 substituents. Or, let's maybe change color. I could number 1, 2, 3, 4, 5, 6, 7. So what one should I do? The one that has 7 carbons because that's a longer carbon chain. Okay, and then let's look at another way we could number this. We could go 1, 2, 3, 4, 5, 6, 7. Still long carbon chain. So which one should I do there? Should I do the purple, this one, the 1, 2, 3, 4, 5, 6, 7, or should I do 1, 2, 3, 4, 5, 6, 7? Good. So if I do 1, 2, 3, 4, 5, 6, 7, then this is my first substituent at 2. If I do the red one, then my first substituent doesn't happen. I have 2 of them, but they don't happen until 3. So you're right. We should go with 1, 2, 3, 4, 5, 6, 7. Okay.
So do you just like count like the chain itself and like the things that hang
The
outside
carbons,
of
the
it?
carbon chain. Yep. Good. Yes, the carbons. We care about the carbons. Okay, so how about this one? So I guess this methyl group would be at position 1, 2, 3. So how about this one? How should we number that carbon chain?
Start.
From the top of that.
Yeah, so where do you start at the top? Because you got those 2 groups.
Yeah, you want to start at the top.
Okay, I'm hearing that we should start up here. So let's try 1, 2, 3, 4, 5, 6, 7, 8. This one would be at 5. That doesn't matter. We care about the end. So we have 2 groups at 3. If we went this other way, we would have 1, 2, 3. We would also have a group at 3, but we'd only have 1 group at 3. This way, we have 2 groups. We have 2 groups at 3. So we would want to do that. It would be at 5.
So the groups do matter. If it's
The number of groups do matter. Yep. So we're reducing more. These are both at 3, and this is only 1 at 3 if we count this way. Yep. Good.
So you basically just want like the biggest group to be at the smallest number.
If you have a choice, you want more at a smaller number. Yeah. So there's 2 groups at 3 instead of 1 group at 3.
So what if there was, so if there was 2 groups at 3 on that side,
Mhm.
the blue one, and only 1 on the other one?
Then what would you?
Or I mean like 1 on 2, would pick 2 then.
Oh yeah. Yep. For sure you pick 2.
Okay.
Or if there's one here, you go that way. Yep. Yeah. So it all depends on, and there's lots of different combinations. Yep. Good. Okay. All right. So we also need to be able to name the longest carbon chain. So if it's just in a chain, then we figure out how many carbons it has. If it's in a straight chain, then we're going to call it, if it has 5 carbons, we're going to call it pentane. Or if it has 3, we're going to call it ethane. Or actually propane. But if we have side chains, we're just going to find the longest parent molecule, count that, and that's going to be the name of the parent hydrocarbon. So let's look at some examples. So what's the longest carbon chain for this molecule? Let's turn on our pen again. Oops, I need to clear that, sorry. Okay, good. So let's also, what way would we number this? Good. Yep. So we could go 1, 2, 3, 4, 5, 6. That makes this methyl group at position 2 instead of this methyl group at position 4. We have 6 carbons in our main chain. So it has 6 carbons in the main chain. That's called hexane. So the main thing would be called hexane. And then next time we'll talk about what else to call it. Okay. And how about this one? What's the parent molecule here? Good, this would be butane. So we're not counting all of the carbons. If we were counting all the carbons, that would be pentane. We're just counting, we have 1, 2, 3, 4. So we have 4 carbons in the main chain, that's called butane. Okay, and then we have a methyl group at position 2. Okay, questions on that? We're doing okay? This is kind of new. I think it's new, maybe it's not new. All right, you have this chart. So you need to start recognizing substituents. So we saw a few in this slide. So here we have a methyl group. We have a methyl group over there. So depending on how many carbons are poking off, that's what we're going to call it. So if we only have 1 carbon, that's called methyl. If we have 2 carbons, that's ethyl. We have propyl, butyl, pentyl, hexyl, and you can keep going. Okay. The ones in this next table, these are the ones that Alex thinks are most important. So methyl group is the same, ethyl, and then propyl can have 2 ways of looking at propyl, okay? So propyl could be directly, so let's draw. So if we have some chain, we have some carbon chain, and coming off over here, we have a propyl group, we have like 1, 2, 3. I'm making this up off the top of my head, so we might end up messing up our longest carbon chain. But if this was something that was coming off a molecule, it has 3, this is a propyl group, okay? But I can also have something like this, where this is also 3. Once you get past 3, you can have different orientations of the molecule. So this is one version, this is just propyl. If I have something here, I have carbon, carbon, carbon. This is called isopropyl because it's bonded to the middle of that carbon chain. So watch out for that. Okay, questions on that? And that's on here, that's on the bottom. So that one comes up occasionally, watch out. Okay. And oh, here's a good example of our iso. So we have this carbon chain. First, what would the parent carbon chain be called? Dude, this would be octane. Oh, that's what I heard. Maybe I was just listening for that. Because I have 1, 2, 3, 4, 5, 6, 7, 8. And then what is this substituent? Good, this first one is methyl. And what's this one? This is that weird. Good, this is propyl has 3, and we are going to specify that this is isopropyl. Yes, you're going to have to specify. Yes. When it's like a triangle, yeah. Yep. The other option would be if it was like that. 1, 2, 3. But we don't have that. I don't know why I turned black there. Yeah. But yeah. Yes.
I think my keys fell out of my pocket during the assembly.
Oh, yes, go check. For sure.
So just the normal propyl is like when it's like in a line and then the other one is when it's like a triangle.
Yep. So if we had, we'll just put one here. If we had this, that's 1, 2, 3. Normal would be, that would be propyl, boring propyl. This is isopropyl.
So when it's off one of the edges is propyl.
Yep, and then if it's off the middle, it's iso. Good. Okay, I think we're almost done, so hopefully you have some time to practice. Okay, this last thing that we need to talk about is if you have a chlorine group, or if you have any of the halogens. I've only seen chlorine come up, but if you have any halogen, we're going to call it not any halogen. If it's chlorine, it's going to be a chloro group. If you have a fluorine, it's going to be the fluoro group. So this would be, we would have 1, 2, 3, 4, 5. This would be pentane, and chloro would be at the second spot. And that's going to be important because Alex might ask you to draw chloro at the second position. and you're gonna have to know what a chloro group is. A chloro group is just chlorine somewhere. Does that make sense? And we'll talk about naming next time.
So what do you mean by like at the second position?
Oh, so maybe I have something like Alex says draw hexane, 1, 2, 3, 4, 5, 6, and draw chloro at the third position. So I'd go 1, 2, 3, chlorine.
So when it doesn't have any side groups, can you just put it wherever, or do you go?
Oh yeah, yep.
So it could go there.
It could also, yep, so it would be symmetrical. I think that's the end of first lunch.
Yeah.
Yeah, that's the end of first lunch. If it's symmetrical, yeah, so if I drew this, like this, 1, 2, 3, 4, 5, 6, if I put 1, 2, 3, if I take this molecule and rotate it, it's the same molecule. Yeah. But they're both at position 3. Yeah, yep, good. Okay, that's my last slide. Questions on that? Sorry, the pen wasn't working. That was weird. All right, let me figure out when we get out.